Okay, question 13. Express the following as a single fraction in its simplest form. So I'm actually going to remember to read the question, unlike over here when I totally forgot to read the whole question and ran in and kind of half forgot what to do. So yeah, a single fraction is the first bit, and then simplest form is the second bit. So how do we get these two fractions together? Well, like any two fractions, we need to have a common denominator. Okay? So if I do a half plus a half, that's going to give me, well, 2 halves, which is 1. Okay. If I do a third plus a third, that's going to give me 2/3. Okay. So common denominators can just be added together. And if you think about it, it's a bit like for like. Okay. So 1 half plus 1 half, 2 halves. Okay. It's about like saying 1 car plus 1 car is 2 cars. However, if I say, a half plus a third, what a lot of people do is add the 1 and the 1 and then add the 2 and the 3. So they'll say, 2/5. But no, you actually can't do that question because you're not adding like for like. That's a bit like saying 1 car plus 1 van is 2 cars or something. Do you know what I mean? You're not really answering anything meaningful. Okay, so you need to make these two numbers the same. So to make them the same, we do our smile and cross. Okay, so 3x minus 2 plus 5x plus 1. So smile is this bit. Okay, where we multiply these two numbers to give us our common denominator. Okay, so that's going to be x minus 2, x plus 1. So usually, if we've just got normal fractions, it's numbers, isn't it? So again, let's use an example. Let's say, 2/5 plus 3/4. So the smile here would be 20. So in this example, we've just got our, it's just algebraic, but it's still the exact same method, okay? And then we do the cross. So we do this number times this number, and this times this. So that's going to give us 3x plus 1 and 5x minus 2. So again, with our simple example, that'd be 4 times 2, which is 8, and 5 times 3, which is 15. And then we just add them together. So that would give me 23 divided by 20. Okay. So if I was to add these together, we see that's just 3x plus 1 plus 5x minus 2, and that's divided by x minus 2, x plus 1. Okay. So that's the first bit, a single fraction. We've done that, okay? But can we simplify it any? Well, we can't just cross out these, for example, because they're part of two separate terms, okay? If they're part of one term, yeah, we could, but because they're two separate terms, we can't. So this question, to simplify, is making us multiply the brackets out. So that's 3x plus 1 plus 5x minus 10, okay, divided by the common denominator. Okay, but we can go further, can't we? Because we've got like terms. We've got 3x and 5x. Oops, I'm bad. I do apologise with the pen. I keep terrible with it. If you watch all these videos, you must be like, God, this guy does not get better with this pen. That's 8x. We've got 3 plus 5. And then 3 and minus 10 is going to be minus 7. Okay, that's x minus 2 and x plus 1. So, yeah, read the question, unlike what I did earlier on, where I kind of didn't really read the question, positive power. I just knew to put it into that form, but clues are in the question. So a single fraction, we did that, and you're getting your first mark for indeed working out your correct common denominator. Okay, so that's 1 mark. You get your second mark for this line here, knowing that that's what you get. You add the two fractions together. So yep, there's your 2 marks for your single fraction, and then you get your third mark for multiplying the brackets and simplifying. Okay, so pretty straightforward. Smile and cross. So just remember the smile and cross when you come to do these. Don't get confused because it's a different layout from standard fractions. Okay, and if it helps, just imagine it was a standard. Imagine that was 3/4 and 5/6. Okay, how would you do the question? It's the exact same, but now instead of a number, you've got x minus 2 or x plus 1. Okay, good stuff. Okay, so that's question 13. Question 14, do we have time? Loads of time, loads of time. Okay, so solve the equation 2 tan x plus 5 is equal to minus 4. Again, I don't enjoy these questions in the sense that I find them enjoyable, but I think they're easy marks. Okay, I do actually quite like some of the similar shape stuff for some reason. I think they're quite good fun. What else did I quite enjoy? I think the volume questions, I do enjoy them for the marks, but I think they're tangible. Maybe that's it. I like things that are tangible that I could imagine relating to real life in a very easy way. Whereas I suppose this doesn't. I don't think that's applying to anything right away, you know. But yeah, I think this is a great question because it's easy marks. All right. So first thing, let's just say again, people see sine, cos, and tan and they switch off. They think, nope, I'm not doing it. Okay, don't. Okay, let's just imagine instead of tan x, okay, that was just x. And I know some people still switch off when it's algebra. Okay, but this surely is something we can do because we've been doing it since first year. So imagine someone said 2x plus 5 is equal to minus 4, solve for x. Okay, now surely most people could have a bash at that. Okay, so just the same as we did before with the working line, how are we going to move over 5? Okay, well, solve for x, so we go for the things that are furthest away from x to begin with, so we know 2 is last. Well, it means it has to be 5 first, then 2. Okay, how do we get rid of plus 5? We take away 5. Okay, so that's going to give me 2x is equal to minus 4 minus 5, which is minus 9. How do we get rid of 2 times x? Okay, well, we divide by 2. Okay, so that's going to give me x is equal to minus 9 over 2. Now, surely everyone can get to that point. Okay, that's not difficult. Now, we substituted in tan x for x, so actually now what we could just say is, just put tan in front of that, okay? Technically, that's not totally right. We really should have another line where we say tan x is equal to minus 9 over 2, okay? But, you know, it's the same thing. X is equal to tan x in this particular case. So please don't stress out the tan's in there, okay? Now, how do we undo tan? Well, we know on our calculators we do shift tan, don't we? Or shift sine or shift cos. Okay, now that can be rewritten as tan to the minus 1, 9 over 2. Or minus 9 over 2. Okay, so that's the only bit so far where I've had to actually even think about SOHCAHTOA. Okay, now this is the next slightly tricky part. So whenever we do this, we're working out we're working out an angle, aren't we? So if we draw out, I'm not going to draw tan out because tan's pretty hard to draw it. Say we were doing sine, cos, or sine or cos, sine, okay, let's just say sine. What we're doing here is we're saying, well, for this number, what's my angle? Okay, so the angles are all the values along here, and this number will be the height up the way or down the way. Okay, so minus 9 over 2. Again, it's not a great example, I suppose, because usually the standard period for these things is 1 and minus 1. So say this came out as 0.5. Okay, we'd be looking for the value or 0.5 there. So we're looking for the angles that correspond to that. Okay, so that number and that number. Okay, here and here. That's what we're doing. We do the shift. We're going in the opposite direction. Usually, we'd say tan of 90. Sorry, sine of 90 gives us 1. Sine of 180 gives me 0. So we're working out the number on the y-axis from the x-axis, but here we're doing the other way around because we're doing shift. We know what the number on the y-axis is. We're going to work back to work in degrees. And you'll see here there's 2 answers. Okay, and that's the same for all these things. Okay, because as you go along, you're going to hit 2 points on the graph. Okay, so the first thing that's very important to do is no matter what, if this number is negative, doesn't matter, work out the positive number. Okay, so what I would do is then say tan to the minus 1 of 9 over 2 is equal to, I'm dropping my calculator. I would say that, okay? So I'm going to do shift tan of 4.5, which effectively is, isn't it? Shift tan, and that's 77.47 degrees. My calculator's doing something kind of odd. What is that doing? 0.26. Okay, so that's going to give me 77. I'm just going to round it to make life a bit easier. 77.5 degrees. Okay, so now we're looking at our cast diagram. Okay, I call it all smokers take cancer. That's what I learned, but cast seems to be the more up to date way of saying it. What we've just worked out, okay, is the angle in here. Okay, so in this first quadrant where everything is positive, we've worked out that number. And no matter what, we should always start off there. Okay, it's always good to start there. Don't put a negative in here, it just makes life really confusing because your calculator can give you some strange answers and trying to work back is annoying. Okay, just always work out 77.5. Okay, now see, this was a sign question, okay, and it was sine of -1 is 9/2. And we said, okay, well, sine -1 positive 9/2 gives us this. I'd then be looking for where is sine going to be negative because we've got a negative result here. So sine's negative here and here because sine is positive here and here. All smokers, right? A and S, that's where they're all positive here. Sine's positive here. Tan's positive here. Cos is positive here. Okay. So we've got tan. So we're looking for where's tan negative. Well, tan's going to be negative in this quadrant and this quadrant. So now we use the 77.5 to work that out. Okay. So in this quadrant, okay, the 77, the angle is all the way around here. Okay, now how do we work that out? We do 180 minus that theta that we've worked out here. That's theta. Okay. Okay, so that 180 minus theta is this big angle. Okay. And in this quadrant, it's the same thing. So we want to go all the way around again from the beginning, all the way around to here. So how do we work that out? Well, we do 360 minus theta. Okay, so 360 would be here, take away theta brings us to there. Okay, 180 minus theta, that's the same as saying 180 takes us to here, take away theta. Okay, so if I kind of draw that out with the thetas, that's theta in there, there's theta in there, there's theta in there, and there's theta in there. Okay, it's like that. So if we want to know from the beginning all the way around, that's 180 minus theta. Okay, if I want to go all the way around to the next quadrant, that's 180 plus theta. Okay, so try and keep that in your mind if you think, okay. But that's what we're doing, okay. So we know we're going to be in quadrant 2 and quadrant 3. We have to be quick and run out of time. So I know it's 180 minus theta and 360 minus theta as well. Okay. Again, some people just remember these. Some people just say, I can remember that, fine. Cool, that's no problem. That's not exactly how I go. But yeah. So 180 minus theta for quadrant 2. It's 102.5 degrees. And in quadrant 3, 360 minus 77.5, that's 282.5 degrees. Okay, I'm in for time. Still some time. So marks for that one, you're just getting a mark for this first point for working out this. Yeah, that's this line here is your first mark, and then second mark and third mark. Okay, so I think there's a little bit in that. There's a little bit of knowledge, not assumed knowledge, but there's a little bit of knowledge to get to the final answer. So you have to know to rearrange, which some people might be unhappy with because tan gets thrown in and all normal thinking goes out the window. When you get to this minus, some people just put that straight into their calculator. So let's just see actually what do I get. Say I put in shift tan of minus 9/2. Now some calculators might be different possibly, okay? So if I do that, I get minus 77, okay? So I could have done that and then just made it positive, okay? But so if you do that, let's see if I did sine of minus 9 divided by 2. Shift sine minus 9 divided by 2. Yeah, I'm getting some funny answers there, so I maybe have to leave that just now. But point is, oh yeah, I mean, I'm going to go for that example. Point is, make this positive, okay, to work out your theta, and then it's the theta that you're going to manipulate depending on which coordinate it's in. Okay, so always work this one out. Sometimes that'll be your answer, like everything's positive here. So if you do have a positive number, that'll be your first answer for your first quadrant. And then if it's sine or cos, they're positive here and here. But for the negatives, just do it positive first, and then okay, right, thanks.